Okay, the Weissach effect, and the Weissach effect was coined, a phrase coined for the 928, and the axle on the 928 was designed with some compliance to achieve a toe-in when the throttle was lifted, or if there was sudden braking in during a turn. So under drive, obviously the wheel here would rotate in this direction, and the Weissach effect on the 993 has been further developed and included in the design. So in essence, I can't drive the road wheel and I can't brake it, but what I can do is show you the effect. So if we transfer to the plan section, and I grab or press so if we can imagine, we are now going to accelerate. What will happen is the toe will toe out as per the program. Not a massive amount, but sufficient, and you can see that toe out is being allowed by the compliance bush moving outboard, and you can see there that the wheel is toeing out. So when we accelerate, so you can see how this works now. So you've got a stiff in compression toe link arm, and if we brake, sorry, wrong way, and we brake, you can see that the toe arm will push the back of the wheel out. You can see the ball joint there moving in response to the force being applied inboard. So inboard produces a toe-in effect. So that's braking in a turn, and then if we lift off in a turn, we get the same toe-in. That then catches there's a lateral load on the wheel, and produces a steer effect which counters the front axle and produces a safer understeer. The kinematic toe arm, or the kinematic arm, so we get changes in toe as a result of the geometry of the arms in space. We can adjust, and just to again walk you around this model and talk about the parts that we refer to as the toe link, the A-arm, the kinematic toe link, which is adjustable at this point, and the other link arm, which is the camber adjust link arm. So we'll come on to the effects of these just now, what the effect of changing the length of the kinematic toe arm. People want to do this, or need to do this, when the car is being used for sport use potentially, because they don't want the safety aspect. So we're going to adjust the length of the kinematic toe arm here. We're going to see the effect in real time to the geometry, static geometry, and what happens at the wheel. So I'm going to move this in and out. So you can see that changes the camber, but it also changes the caster of the rear wheel by in and out. So next I'll show you the impact of that adjustment, which we can make when we're doing a 993 geometry. So you can see I've increased the length of the kinematic tow arm on the eccentric adjuster at this bush here. It's a rubber metallastic bush. You can see that that has now affected the rear camber, and we're in positive camber. But the key here is what happens when we move the suspension. So watch that toe as I go through bump now. You can see that this now tows out through bump, which is a dangerous place. That's not soft, that's not stable, and that's not agile, or maybe too agile. So that develops a toe out. That's a toe out, which is unstable. Now let's shorten the kinematic toe link, and we see what effect that has on the steerage of the wheel. You might want to call it bump steer. We've shortened the kinematic toe link now, and we've got back to slight negative camber on the rear left wheel. And to prove how that affects the bump steer characteristic of the rear wheel, let's put it through some bump, and you can see there now we get toe in. So kinematic toe and the 993RX is really quite complex, because it comprises of two things. The kinematics of the links given by the links will present a path in space for the wheel to follow, which is beneficial. The kinematic or compliance link helps, which is the application of force laterally, i.e. when we're in turn, moving the compliance bush here, producing toe in, and the model shows that really quite well. On the actual car, this point here is an adjustment point as well as a bush, and you'll see an eccentric adjuster here, and the same with this one here, another eccentric adjuster. There's a third eccentric adjuster, which is up buried down at the back here, which is on the what we call the camber. We find if these have not been, if the car hasn't had its geometry done or a wheel alignment done in many years, we tend to find that these points are prone to seizure, and which necessitates then us having to cut them out with a reciprocating saw, replace the bush and the eccentric bolt that goes through. It's really important that these places are all free, so it doesn't compromise how the wheel is set in terms of toe and camber. And of course it's critical that we adjust the kinematic toe, and we do that by placing there's two ways of doing it. One is to place the OE, the factory tool, on the wishbone here, and on the control arm, on the toe control arm. Another one is the Autometrics tool, which is the Motorsport, what we call the Motorsport tool, but specifically Autometrics, which attaches to the wheel carrier here and measures this, in essence, the angle of inclination here of this angle here. It measures that angle in relation to the vertical. The key is that when we set the kinematic toe, that whatever we do for this wheel, we would do for this wheel, which is not here. But so we've had some traits and characteristics that you might want to be aware of when the kinematic toe is set incorrect. A surefire way of determining whether the kinematic toe is set incorrectly or is unbalanced across the rear axle is, as we remind you, when the wheel goes through a bump, it goes through a programmed toe in, which is on the manifest of Porsche's stability program. And if you can imagine, if the kinematic toe affects the bump steer, for example, the kinematics of the toe kinematics, then if it's different on the other wheel, for the same bump, the wheel will steer. The consequence is that the rear of the car will tend to steer laterally over a straight bumpy B road. The other characteristic is that if you're turning on a wheel which has got its kinematic toe setting correct, as I showed you earlier, we can get toe out produced on the rear wheel, and which gives an unstable toe and turn, and potentially you might find that you might get a bit of understeer, or you might get massive oversteer. So it's important that we set the kinematic toe using the tool. The workshop manual says that if we adjust the camber here using this link arm and adjustment at this point using the eccentric adjuster, then we must also adjust the kinematic toe into the right range. If geometry is being done and we only change the toe on the toe link arm here, then we don't have to obviously recheck the kinematic toe or make adjustments here. So we were talking about the tuning and maintenance of the LSA rear axle, admitting and accepting that some of these components now have done 150,000 miles. The cars are as old as 27 years old, and that takes its toll. We find that there's three main issues with the axle. The design, remember, is that each of the bushings at the end of the links on the inboard, here, here and here, these specifically are hard rubber bushings, where there's a compensating bush here, which is supposed to be soft rubber bushing. The ball joints also, there's five ball joints there, including the one at the front of the A-arm here. This one takes a lot of load, and we find that if there's wear in the ball joints, that's a knocking or a clicking. We find that this one is culprit, and this one here on the toe control arm, and also the one on the bottom of the outboard of the A-arm. And we check for those before we do geometry and advise replacement if there is any slack there. The other issue that we faced with is specifically at these points here and here, which are also adjustment points for geometry, is corrosion of the aluminium, specifically the rubber aluminium bush, which then leads to delamination of the rubber from the aluminium, and produces a loose effect. So the bush then becomes loose, i.e. the forces being transmitted up and down these links are not being resolved, and are pushing the link arm outside of its programmed path, both in these 3 points. So best to replace these bushes with OEM. We very rarely see issues with the inner bush here, but if we are going to have to replace the A-arm because of the ball joint wear, then typically we will, if we can't find an original OE replacement, we will take this bush out of the outgoing arm and fit it into the new arm, so that we've got the same amount of compliance across the rear axle. The only other thing then is this: if we see this as the adjuster, for example, this is an eccentric adjuster, so as we turn it on the actual car, it will make this link longer or shorter, and we tend to find that these C's also, so this one and the camber one and the toe. So for any geometry, these obviously need to be free and lubricated. So there you go. There's the maintenance issues and maintenance points also identified, just to give you a bit more information on this LSA axle, which is the predecessor to the same multi-link suspension on the 996 and on the 997, and the derivation also on the 991. So investment in the future by Porsche, going from the trailing arm to the multi-link suspension. There you have it. Hope that was useful.